All right, I'm gonna do 3 videos for 10.5 polar area. So here, part one. There's 3 examples, and it takes me time to set up all the graphs. So I'm just gonna do 3 videos. All right, video one. Example one, we have the equation r equals 3 cosine 3 theta. So here's its graphed. All right. Now I don't have the directions here, but in your notes it says find the area of one leaf. So we got to find the area of a leaf. There are 3 leaves that we can see, and they're all the same area. They're exactly the same size. All right. But what people get confused on is this picture goes through twice, and you don't know that unless you watch it graph or you trace it. If we were to graph it and then push our trace button, just push the right arrow and just go around this thing, you could follow along it. So it goes like this, and then it comes up here, and then it finishes here, and that's at pi at 180. Then it continues and does the same graph again. All right. So our formula for area of a region is 1/2. So that's part of the formula, 1/2 from alpha to beta, from what angle to what angle of the radius squared. So your equation squared. So it's really 1/2 your equation squared. It's a pretty easy formula. You're like, the letters don't match, but your equation r is always in terms of theta, so you'll have theta d theta. Okay, so we can take the integral. All right, so the whole key is what's alpha and what's beta. The hardest part easily is where it's at. So the area of this guy is going to be 1/2 some integral I don't know yet of this function squared. All right, 1/2 function squared. Now, the key is you got to know when one of these leaves are made. Well, there's ways of just tracing with your calculator. That's what probably 80% of the class will do. There's mathematical. Maybe some of you really strong trig people might like the mathematical way. So I usually get a few do it that way. So there's some different options. If you would watch this graph, it actually started at 0, and by 30 degrees, at 0 it was 3, and at 30 degrees it was 0. So it just jumped to 0 in that first little 30-degree slot there. So that's why it hits there quickly. All right. But then it continues on and does this half loop and then finishes it. So if I want to find the area of a loop, what is the integral? Well, it turns out every loop is formed by 60 degrees. All right. So for example, 0 to 30 is that first half. Okay. So if I took an integral from 0 to 30, so 0 to pi over 6, and punch this in the formula, I would actually get this little half area. So technically I could just double that and I'd have an area of a leaf. That's one technique I could do. All right. If I want to do a full leaf, this leaf started at 30 degrees. We went from 0 to 30, started here. So from 30, and it turns out 90, it hits here. So if I take an integral from 30 pi over 6 to 90 pi over 2, I will actually get the area of this leaf. So I could have many choices of doing this. I've had students go, can we just do 0 to 2 pi and divide by 3? Well, remember, 0 to 2 pi is all the way around, and this thing actually goes around twice, so it actually makes 6 leaves. So if you did 0 to 2 pi, you would have to divide by 6, and that would give you the area. All right. So there's a lot of different ways to do it. So how do you find out what it is? Well, on your calculator, okay, you switch you're in polar mode. But if you look at, let me see if you guys can see, I don't know if it's visible, maybe that is. If you guys see where it says step, all right, and it's kind of highlighted right now, where it's beeping. See, that's 0.13. All right, I kind of mentioned this before. That's your factory setting for pi over 24. So it's set at pi over 24, which is 7.5 degrees. You can actually type here and change that. I could type in pi over 12 instead, which is 15 degrees. Now, why is those so important is it'll tell you if you count the number of pushes, every time you push the right arrow, the calculator moves pi over 24. That's what the step is, or 7.5 degrees. So if I want to graph this, your cursor would start here where the graph started, and you push the right arrow and count how many pushes till you got to here. So you would actually do 4 pushes, and you're like, well, 7.5 times 4 is 30 degrees. You're like, oh, so this graph from 0 to 30 is when it hit there. Now you got half of a leaf, you can find the area and double it. That's one way. All right. If you want to keep pushing, you pushed it 4 times to get to here. Well, you can push it 4 more times and then another 4 more times. So, for example, if you start at 4 pushes, 30 degrees, that's where it starts. That's where this starts. So then you push it 4 times and then 4 more times. So push it 8 times. So 8 times 7.5 is 60 degrees. So 30 plus 60 is 90. So you can just count how many pushes you have, and that will tell you, when the leaf is done. Okay? So when you type in your calculator, it won't show 0, 0. Remember, your calculator is doing approximation, so it might say like 2.3 times 10 to the negative 4 or something. Negative 4 means move the decimal, and that's like 0.000. That's technically 0, so we can use that as 0. All right. Now those are the ways that most people like to do, just counting with their calculator. So you should practice that, graph it, and then push the button and see how many do it. Now a lot of students like to switch the step to be pi over 12 or 15 degrees. It gives you half as many pushes, which is kind of nice. So for example, if you had switched it here and you pushed it, it actually will go 2 pushes, because you're going to go, oh, I did 2 pushes. So a little trick to doing that, let's say we're going to do it pi over 12. Okay? It took 2 pushes, so if we start at 0, 2 pushes would be 2 pi over 12. 2 pi over 12, 2 pushes. And that would give you 0 to pi over 6. That's that first half a loop. All right? If we want to start from here, we're already at 2 pushes. So we're at 2 pushes, 2 pi over 12, pi over 6. And then you would count how many pushes. And you would get 1, 2, 3, 4 more pushes. So if we're at 2, 4 more pushes would be 6 pi over 12. And again, that's your pi over 6 to your pi over 2. So that is your how you can just count how many pushes. So this pi over 12 is a good one to switch to speed up your counting. But your graph is way more accurate looking when you do this one. It graphs every 7.5 degrees, so you get a better look at the graph. So that's why you got to kind of go back and forth. A lot of people like this one only because they can see a better look at the graph. All right. So on the equation, the other way of doing this is mathematical. You could set the equation equal to 0. Now, why you set it equal to 0? You're trying to find out when the radius is 0. The radius is how far you are from the center, all right? And so if how far we are from the center is our radius. So when we're in the center, the radius is 0, okay? So to do this trig, divide by 3. All right? And then when is cosine 0? Now cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. It's constantly 0. Just at 90, if we keep going back and forth, even the negatives. So when you do arc cosine to get these values, that is 3 theta. Because see what happens, you're doing arc cosine of 0, gives you all those values, and then your angle is 3 theta. So you divide by 3, you get pi over 6, 3 pi over 6, which is pi over 2. Then you get 5 pi over 6, 7 pi over 6, and so on. Now what those represent is every time in 0. So you notice pi over 6 and pi over 2, those look familiar. So what happens is pi over 6 is the first time, and then pi over 2 is the next time. So if you could just take an integral from here to here, and that'll be a leaf. You could take an integral from here to here, and you have a leaf. So that's mathematical. A lot of students, their trig isn't strong enough, and they're like a little nervous about it, so they shy away from this way. All right, so those are the different options, as I said, to find the area of this leaf. So you guys should practice it while we're doing this. Type in your calculator. So as I said, the first way I could do it is I could start at 0, And to get to the center was half a leaf, and that was 30 degrees, so pi over 6. You get that answer and you double it. We should get a value of 2.356 final answer. All right, that would be integral. I could also choose to count. So I count here and I go, all right, I counted and it was, let's say we'll do the pi over 24 this time, just to do something different. All right, so if I started, if we want to do this leaf right here. So it took me using pi over 20, the factory setting, it took 4 pushes. So I've already pushed 4 pi over 24. I've made 4 pushes just to get to 0, okay? Now, once I get to 0, now I can start a leaf. So if you count, you're gonna get 4, 5, 6, 7, 8, you're gonna get 8 pushes. So 8 more pushes, we're at 4, would be 12 pi over 24. So that reduces to, and that's what I told you earlier, pi over 6 to pi over 2. And if I take an integral from pi over 6 to pi over 2, that will give me this leaf. If this is from pi over 2 to 5 pi over 6, that will give you the same answer of 2.356. All of these will give you 2.356, all these techniques. All right? Now, if you did figure out that this went around twice and that it made 6 leaves, you can take an integral from 0 to 2 pi, and that will give you an answer like, what is that, 14 point something, you know, give you this huge answer because it's counting all the leaves. All right? So, and then I would divide by 6 because there's 6 leaves, and you'll get your 2.356. All right, so try a few of those and see what happens here. Now let me explain to you again what this radius is. When I take an integral, let me just do the first one from 0 to 30 degrees. What your calculator is doing is it's adding up these radiuses. So it's finding the area. It's not like when we do area, we're just going like this, all these rectangles and, you know, our left and right and all that. We're not finding the area straight up and down. We're actually finding the area from the origin. So it's like a sprinkler. It's always like a sprinkler watering an area, okay? So pretend your sprinkler's right here and you shoot to the graph. And that's the area that you're finding. So I'm finding the area here. And then so if I go 0 to 30, I'm finding the area, I'm adding up all those different lengths, all those radiuses. You see the radiuses are getting smaller. They get to the origin. So again, that's half a leaf. So that's the one I would have to double. So if I did 0 to pi over 6, I would double that. So I'd multiply by 2, the 2.5 would cancel, and that would give me 2.356. All right? So that's example 1, a lot of talking for it, but that's kind of how you do your calculator, it's how you do your other stuff with that. All right, I'll do 2 more videos for the next 2 examples.